For intersections, what we're looking at are collections of elements that are common to, in this case, both sets. Although we can talk about more complex things as we'll see later on in the chapter, but for now we're just looking at pairs, where what we want to think of here in terms of a Venn diagram would be something like the overlap between two circles that happen to share a region. That shared region in particular is the intersection. So when you see an intersection, or when you're trying to find an intersection, think in terms of the word and or the word both. Those are what tell us about the intersection between pairs of sets, where, to be more exacting in our notation, we say A intersect B. That thing that looks like a N there, it's called the cap, says intersect is equal to the set of elements X such that X is in A and X is in B. It is in both sets of things simultaneously. So let's take some quick examples here to understand what it is that we're looking at. So for this, we have the sets A is 1, 2, 3, 4, B is 3, 4, 5, C is 5, 6, 7, and D is the empty set, and we want to find A intersect B, A intersect C, and A intersect D. So for our first one, that's the only one that's going to mean anything really, but we'll get to that in a second. We want to take A and intersect it with B. What we're looking for here are the things that we have in both A and B simultaneously. And we can see there that A has 1, 2, 3, 4, B has 3, 4, 5. So A does not have 5, B does not have 1 and 2, but both, the intersection, would consist of 3 and 4. On the other hand, we're talking about A intersect C, A cap C, as it were. We can see there that A only goes up to 4, while B goes from 5 to 7, which means that neither of them have any overlap at all. That is, there's nothing shared between them, and because there's nothing shared between them, if we try to describe the set of things shared between them, it would be nothing. And we have a special name for nothing, at least in terms of sets. That would be our friend, up to my marker not being dead, the empty set. Remember, when we were introducing the empty set, that's how I described it, as a collection of things where you have two properties at once that can't be satisfied. We don't have anything that is in both the set A as well as the set C, so that's empty. And then similarly, when we want to talk about A intersect D, and again, apologies that my marker is having some issues, there's nothing in the set D because the set D is already empty. And if you try to take nothing from anything, well, you'll still be stuck with nothing. So A intersect D will also be the empty set, and that holds generally. That if you take any set and intersect it with something that is by definition empty, then you have to get the empty set, because you can't possibly have any shared things with no thing. So you just get stuck taking the nothing. And that also says that if you have two sets where one is a subset of the other, and you take the intersection, you'll just end up with the subset, where again, trivially, the empty set is a subset of everything, so that's what we get. And this is our example for and, which means we might want to think about whether there's an example for or. And there is. That's where we get the idea of the union.